Today we're going to look at the area of a polygon on a coordinate plane. So with the area of a polygon, what they would like you to be able to do in Math 1 is be able to find the area of a rectangle or square on a coordinate plane, as well as a triangle on a coordinate plane. Now, some of them are a little bit easier than others. For example, with this one, this is a rectangle that you see there in the blue and the red, but it's kind of tilted over. If I had a rectangle, I'm just going to draw this one in here real quick. If I had a rectangle, let's say like this, that one would be extremely easy to find the area of. I would just have to count one of the sides, which is 2, count one of the sides, which is 1, 2, 3, 4. So, for example, this smaller one down here, my area would be 2 times 4, which is equal to 8 units squared. Even though it didn't look like units. But I can be honest with you, in Math 1, very rarely are you going to have a square or rectangle that are aligned perfectly. Most of the time in Math 1 they're going to be tilted. So let me take that one off there. Alright, so usually what you're going to see, similar to this one that's in red and blue, is you're going to see a rectangle that's tilted. So you're going to have to use your distance formula to find the lengths. So at the bottom here I have that area is equal to length times width. So if you didn't remember that for the area of a rectangle or square. Now the two sides on here, I have them color coordinated because it does not matter which one it is that you find. So example, the blue, those could both be considered a length or they could both be considered a width. It honestly does not matter. Same thing with the red. Both of those could either be a length or they could both be a width. It's kind of up to you. So I'm going to say the length is my one in blue. So if I wanted to find the length of that line, I define my coordinates. That top coordinate's at 0, 2. This bottom one down here is at 2, negative 2. So I would have to use my distance formula to find that length. So again, with distance formula, it's the square root. You subtract your x's, so 0 minus 2 squared, plus, subtract my y's, 2 minus negative 2 squared, which gives me a length of about 4.47. So if you don't remember how to find or use distance formula, I'd probably go through and rewatch that video. Alright, so let's say that's my length. So area is equal to my length, which is 4.47, basically times my width. So I found the length. Now I've got to find the width, which is in red. It doesn't matter which one of the two we do. I'm just going to do the one in the upper left corner. So I have one of my coordinates. It's at 0, 2. My other coordinate's at negative 2, 1. That is a 1, it's supposed to be. And again, I just have to use my distance formula. So square root, subtract my x's, so negative 2 minus 0 squared, plus 1 minus 2 squared, which gives me about a 2.24. So there's my width. And again, all I have to do is multiply them. So 4.47 times 2.24 gives me an area of about 10.01. And again, that's going to be units squared because you're looking for area. Okay, so again, for area of a square or rectangle, if it's tilted, again, just choose one side to be your length, one side to be your width, multiply the two of them together, and that gives you your area. Alright, if you need anything from this screen, go ahead and get it. I'm going to switch screens. Alright, so now we're going to look at the area of a triangle. Now, we're actually going to start with the triangle that's on the right-hand side. We're going to start with this one over here. Now, hopefully you guys notice when you look at that, that's a right triangle. Now, right triangles are actually very, very easy, especially if they line up on the coordinates like this one does, to find your area. Area of a triangle is 1/2 times your base times your height. So, my base for this one, I'm going to put it in red. My base for this one is right down here, and since it aligns nicely with my graph, I can just count the spaces. That's 1, 2, 3, 4. That's an easy base. My height is the other side of my right triangle, so that one right there. And again, all I have to do is count the spaces. So 1, 2, 3, 4, 5. So in this case, my area is 1/2 times 4 times 5, which gives me 10 units squared. Alright, so that's a right triangle if it lines up nicely. Honestly though, in Math 1, most of the time they're not going to be. they're probably going to be more like this one over here. That is also a right triangle. It's just sometimes a little bit harder to tell. The way that you can tell that this is a right triangle is if you look at the slopes of the two lines that you think are right triangles. So let's say if I look at the slope of this side over here. Well, this one, it goes down 1, 2, 3, and over 2. So this one has a slope of negative 3 over 2, down 3 over 2. And if I look at this other one right here, that one, oops, let me change my color back. There we go. This one has a slope of, I'm going to rise 2 and run 3. So what do you notice about those two slopes? One is negative 3 over 2, the other one's 2 over 3. Hopefully, what's ringing in your mind is that they are perpendicular. Remember, perpendicular means opposite and flip slope. So that negative 3 over 2 is an opposite flip of 2 over 3. Those are perpendicular. Perpendicular makes a 90-degree angle. So if you're unsure if something's a 90-degree, oftentimes you can tell when you look at it, but that's how you check to see if it's a 90-degree angle. So I'm going to take those off there because we really don't need them right now. Oops. So, okay. So now we're going to go through and find our area. Well, we're still dealing with a right triangle, so one of these is my base, one of these is my height. It really doesn't matter which one. So I'm going to say this one's my base and that one's my height. It really would not matter if you had them the other way. Well, here's the thing. I can't just count the spaces now because it's tilted. So I'm going to have to use my distance formula. So this point over here is at 1, 2, 3, 1, 2, 3, 4. This one down here is at 0, 2. And this point over here is at negative 2. 1, 2, 3, 4, 5. Okay. So now that I have my points, I can use my distance formula to find my lengths. So I'm going to find the bottom one first. So this point is the square root. Parentheses, we want to subtract our x's, so 0 minus 3 squared. Plus, now subtract my y's, so 2 minus 4 squared. That gives me 3.61. Okay, so that's my base, 3.61. This one places the one in the middle. Alright, now I'm going to find the one in red. So again, distance formula. Subtract my x's, so negative 2 minus 0 squared. Plus, I want to subtract my y's, so 5 minus 2 squared. That one gives me 3.61 as well. So, and there's my height, there's my width. They happen to be the same. That's not always the case. So all I have to do is 0.5 times 3.61 times another 3.61. And that gives me about 6.52. And again, that's going to be units squared. Okay. So now we're going to look at ones, if, like I said, if it's a right triangle, the two sides touching the right triangle is your base and your height. So you just have to find those two distances and you're done. Now, in Math 1, they're not all going to be right triangles. So we're going to go through and look at one. I'm going to show you, I know a couple of different ways of finding area of a triangle on a coordinate plane. And for the first couple of years I taught it one way with a formula that I learned in calculus. And some students like that formula. Last 2 years though I've taught it the way I'm going to show you guys, and students seem to like that one a little bit better. It has a couple more steps to it, but the mathematics in it is a lot easier to deal with. So if you need anything from the screen, go ahead and get it. Alright, so let's say we had to find the area of this thing. This is obviously not a right triangle, but we're still going to have to find our area by area is equal to 1/2 base times height. Okay, so what I've had my students go through and do is I'm going to draw this in a different color here. Alright, so what I've had my students do is I've had them go through and make a box first. Okay, now I want to enclose this triangle in a box, and every vertex or every corner needs to touch the outside of the box. So I'm going to box it in. Okay. Now, what I have students do is I have them find the area of this rectangle, which is easy. It's lined up nicely on the coordinates. The area is basically length times width. So my length in this case is just counting the boxes, 1, 2, 3, 4, 5, times my width, which is 1, 2, 3, 4. So this one has an area of 20. Okay, and we're just going to kind of keep that in our back pocket for the moment. Now, in order to find the actual area of that triangle in the middle, we're going to have to erase out, basically that whole area inside that box is 20. But I'm going to have to erase out this triangle right here, because that's not part of the triangle I'm trying to find the area. We're going to have to erase out this triangle here, and this triangle right here. Now, what I want you to notice though, each one of those 3 triangles I have to get rid of are right triangles, and they're lined up right on the coordinate plane, so they're extremely easy to find the area of. So what we're going to do is we're going to take the whole area, which is 20. Okay, so I'm going to take 20, and I'm going to minus each of the small triangles. Okay, does not matter which one you start with, so I'm going to start with this one on the right hand side. So I know that these 2 sides right here, okay, are nice easy ones to count. This is a 1 by 1, 2, 3, oops, I lost my count, 1, 2, 3, 4. So I'm going to have to minus out the area of that triangle, which is 1/2 times 1 times 4. So there's one of my triangles gone. Now I've got to get rid of, I have 2 more to get rid of. So I'm just going to choose to get rid of this one right here next. That one is a 2 by 1, 2, 3, looks like 4. So to get rid of that triangle, it's 1/2 times 2 times 4. And then I kind of ran out of space, but I have to get rid of that 3rd triangle up here at the top. This one is a 2 by 1, 2, 3, 4, 5. This one's a 2 by 5. So 1/2 times 2 times 5. And that will give me just the area of that inner triangle. Now, some people break that down in parts. Some people go through and type in that whole equation in their calculator at once. It's fine. If I were you typing this in your calculator, though, where it's 1/2, I would probably just use 0.5. It's easier to type in your calculator than 1/2. So 20 minus, and I'm going to put those in parentheses just like I have right there. So I'm doing 0.5 instead of 1/2 times 1 times 4, and in my parentheses, subtraction. Again, 0.5 times 2 times 4, and minus in parentheses my last one, which is 0.5 times 2 times 5, which is going to give me an area of 9 units squared. So with these, you're often going to have to use graph paper, but the math in this one isn't necessarily that hard to go through and do. You just have to box your original triangle in, get a nice rectangle, and find the area of that rectangle, which is easy, and then just subtract out the other 3 triangles that you need to get rid of, which are all nice right triangles, just base and height, and then you have your final area to it.